Hello, welcome to Team 11's final presentation for our capstone project. My name is Matthew Novaresi and I'll be introducing our product to you, the Hydro Washer. Just a brief overview of how the rest of this presentation is going to go. Again, I'm going to be introducing the product to you. We're going to show you some of the things that we did last semester in preparation for the manufacturing phase. And then the rest of the team is going to take you through the design changes and individual system build and testing. After that, we're going to conclude with our final thoughts on the project. For a product like the Hydro Washer, there's a large need in Arizona due to the monsoon season they have here. A lot of people have pools, but when the monsoons come through, they're filled with dirt and grime, all sorts of junk. So there's a market for a product that will clean the bottom of the pool and skin it. Unfortunately, the current options for pool cleaning are limited and expensive. Some of this competition includes the high-end pool vacuums that you'll find on Amazon. These are high quality, but they're going to charge you around $700 to $1,000, and that's out of most people's price ranges. And then you also have surface skimming products that, while they do work and they are cheap, they don't give you the quality that you really need. So we have a couple goals for our product to meet those needs. We need a robot that is more inexpensive than the high-end pool vacuums. A robot that's going to be able to clean your pool properly, and it should be able to last for a long time, not dirty up your pool water, and most importantly, be safe. The team went out to do this by establishing 5 key systems. We have the power system, the control system, buoyancy system, cleaning system, and finally the navigation system. For these 5 systems, we went out and defined a series of variables to test what was important to us in preparation for the project. As you can see on the top right, we defined what we would say was good and what was poor. The bottom right is where we define our variables, and then the bottom left is an example of us evaluating for each system. Using these variables, we then calculated a whole lot of stuff. You can see some samples on the far right. And we completed these calculations to decide what materials we were going to use. In the end, the materials came out to this price and weight analysis. As you can see, the product was projected to cost around $383 and weigh around 33 pounds. This is our previous conceptual design completed last semester. Again, $383, 33 pounds. And then our prototype here, the Hydro Washer, came out to be 38 pounds, cost around $300 in materials, and a whole lot of man hours. And to take you through the cleaning system, here's Mauricio.
Hello, I'm Mauricio. I will take you through the manufacturing of the cleaning system. So the big game changer for us was the volume of the original prototype. We based all of our calculations on weight rather than volume. And when it came time to building this thing, we realized that the shell required to enclose the entire system was going to take over 150 pounds to sink. We also realized that this was not something that we wanted to have. So we decided to scale down everything, starting with the cleaning system. Picture to the left is the original prototype. This thing used to be 20 inches long by 24 inches wide. It was bulky, so it needed to be scaled down. So I went through it and I basically redesigned the whole thing by scaling it down. And it came out to be much smaller, only 12 inches long by about 12 inches wide. This is more, this is about half the size, and it turned out to be more practical. This is a drawing of the new system. The picture on the left is the front view, the picture on the right is the rear view. You can see the pump in the centralized area, and that vertical pipe is the flow reverser valve. It's composed of a single canister that houses the filters. And instead of going with a lot of pipes, we just went with as little pipe as possible, and we scaled down from a 2-inch pipe to 1.5. That still gets us the 8,000 liters per minute that we wanted, and it's just basically a lot smaller. So for testing, we did 2 types of tests. The first one is cleaning with a little bit of water. We decided to go with just a small amount of water just so that we could like avoid flooding the entire box and ruining the electronics and whatnot. So for the first test, you're going to see how the device approaches an amount of dirt, picks it up, and after that, the floor is clear. You can see here, that's the puddle of dirt. You can see the clear pipe, it'll turn dark. And then after a few minutes, it turns clear again. That's when the device has processed the dirt. So there it goes dark, and then it turns clear again. Okay, so then the picture in the middle is what the pipe looked like after we were done testing. Some of the dirt was cut up in the groove right there where the different size of pipes come together. And then this test is how the device is going to clean the filters. So basically the flow reverser valve reverses the flow of water, so the water runs backwards through the filters, cleaning them from the inside out. And this is the exit of the water. The water coming out now is murky, and I was manually cranking the flow reverser valve just so that we avoid putting a lot of devices into the water. But as you can see, the water was murky, and then as I crank it, the water stops flowing in the reverse position and it goes back to the original. And to go over the navigation systems, here's Travis.
Well, my name is Travis Smith, and I'll be going over the navigation for the hydro washer. The main features for the navigation system are 2 side wheels, the 2 motors, the stabilizers, the propeller, and all the waterproofing. Our initial design for the navigation system was to have 2 trains mounted on the sides of the shell. These 2 tank treads would be powered by 2 separate motors, and after some testing we found out that the motors we bought were not viable as they weren't strong enough to move the treads. To compensate for this, we used an old Dyson motor with a single shaft. This Dyson motor had a lot more power, and one issue with it is that being a single shaft, we lost the ability to turn the shell. So to turn the shell, we had added our side propeller towards the front of the shell. This was going to be our turning method for the device, and what happened is this got rid of the floating navigation, because our original idea was to have the propeller for the floating navigation. So to compensate for this, we added these paddles to the side wheels, and these blades attached were to act as a paddle boat for the shell. The last thing for fabrication is our waterproofing. Our waterproofing consisted of the pipe seals, PVC piping, pool lube, caulking, and petroleum jelly. And these worked pretty well, except there was some leakage when we did the full testing. Our first testing we did was the land testing. This was just using our motors on the ground surface, and we were able to move 25 pounds successfully. This next testing is for the propeller. And in this video, the propeller is mounted to a styrofoam, and that styrofoam is there to reduce the amount of vibration and for the system. This next test is the waterproofing test of just the navigation system itself. You can see in this video that the shell is being submerged in water just enough so that the holes in the navigation system are under the water. From this test, you can see that there's no water being leaked into the system. The next test was the full assembly test. This test we did have some issues with. You'll see in this video. So we'll start the motor up, and you'll see that the wheels are going to be turning and the box is going to be moving. So you see the wheel turning right there. So what happened is our system actually started leaking on the inside of the motor chamber, and all this added weight and the lack of just grip from the wheels made it so that the box couldn't actually move while it's underwater. Also, because it leaked, it just didn't help with the extra weight. So for conclusion for the navigation system, as I said, we did a lot of new redesign from last semester. We added those side wheels with paddles to replace the tank treads. We added the propeller on the side. The ground and waterproofing testing individually was a success. However, when we did the full system test, the water did leak into the motor chambers. Up next, we have Oscar with the control system.
Hello, my name is Oscar, and I'll be presenting the control system and all the changes that were done throughout the semester for it. The first change was that the added weight of the whole system, cleaning, buoyancy, and navigation meant that we needed a stronger motor. So we had to ditch the original 12-volt motors and go with the Dyson motor that could take 120 volts. And since we can't really have 120-volt battery in the container itself, we had to use a stepper, which was purchased through Amazon, which stepped up the voltage from 12 volts to 48 volts and 8 amps. So this gave us enough power to move the object, our hydro washer, on land pretty well, and underwater pretty well, except we had no traction. And the next thing for control, since we only had one motor and then instead of two, I had to ditch the control modules, which meant that I had to go with a much simpler system of just relays. So I had bursting sequence onto the Arduino, meaning that I'd have 5 seconds on and off burst to keep the power constant so that we could get some sort of traction, because the treads did not work very well and the new wheels still need some help getting some traction. And for buoyancy system, we had 3 initial design changes. The first one is a piston system, which had one of the 12-volt motors attached to a gear and attached to a racket pinion, which will move a piston left and right to take in and take out water. Here you can see a video of it working. As you can see, hopefully, as you can see, the piston moving in and out on its own, which is the connection to Arduino and the power supply perfectly well. And the programming wasn't any difficult from the previous programming for navigation, so there was no really headache caused by this. The next thing we needed to do was upgrade the motors. Once again, from a 12 volt to 24 volt. 24 motors were provided from a used 1979 Ford Bronco door mechanism that would lower raise the windows. The other issue with this that was presented was that I needed a stronger motor controller, meaning that these motors that were these new motors needed 4 amps at 24 volts, and the controller I bought originally was only for a 12 volt 2 amp, which made that have a heavier duty module, which is seen here on the right. And this would do us as a benefit of increased speed and stability. And here is the buoyancy working with the 24 volt piston system. As you can see, it's pumping out water, everything's working fine, the battery is sealed inside our initial test box. And finally, the final modification to the buoyancy system was to ditch all that programming, all that relay, all that specking for controllers, and just go with the simple voltage pump system, which used again the relay bank that I previously purchased to keep one of the voltage pumps on to pump in water into the tanks and to activate the other one once the water was full. In the other tank. So the programming was super simple on this, and the battery, there was no extra battery load required for this or extra current load required for this. And for cleaning system, there were no major changes. Everything worked accordingly like it did previously. We still use a 24 volt. We still use the original module that was controlling the water pump, and still used it for the same amount of time. In charging, we wanted to use a self-charging modification. For self-charging, which basically had 2 inductors, which we bought from Amazon. One would be attached to the wall, and one would be attached inside the unit itself. As you can see here, we applied the voltmeter to see how long it would take to charge. The only downfall of this was that it would take too long to charge the batteries properly. So we were about getting a 0.24 voltage reading going into the batteries, which meant we needed like a charging time of 8 hours to get a complete full charge. But it worked as we did design it initially. And finally, the points, 100 points.
name is Alejandro, and I will walk through the process for the buoyancy system. So this was our initial design. We used a piston and PVC pipe to push water in and out. You can see on the right, this is a whole hydrologic system, and the tanks would have been mounted on the top. But we ran into a little problem, and this was not enough weight to sink the system. So since we needed more weight to sink the system, I went ahead and updated and made some changes. So I still kept the rack and pinion method, but this time I added a pump and made holes on this end of the PVC pipe to allow water in. And then when we didn't need water, we would push it and cover it so that no more water would come in. And then when it was ready to rise, we started the pump so you could pump out the water. So we ran a test, and the system rose and sunk, but we needed to find a way to balance it. There was more issues that arose. We needed more space for the other systems, and from the previous test, the container was unbalanced. So in order to update it again, we added 2 tanks on the outside to help with balance, and this would create more space inside the system because the tanks would be on the outside. And each of these tanks would be connected to hoses, as you can see on the right side, one being the inlet, one being the outlet. 2 bilge pumps were used to drain the water out and pump water in. So this is a schematic of the final design. This is how it should have worked, where the water goes in through this pump, and then into the tank, and then to this hole where it will start to fill up the hydro washer. And then when the tank and the hydro washer are all full of water, it starts to sink. And when it's ready to rise, it would go up to this bilge pump, take all the water out. And then the breather tube is just there to let for atmospheric pressure, so that there is no increase in pressure in the system. So towards the end of the semester, we ran into a little issue, and this bilge pump was not able to fit inside the hydro washer, so we went ahead and stuck it on the outside. But this time it would only drain and pump water into the tanks only. And since for testing purposes, this is what we did. So the pump was malfunctioning, tanks were not getting filled, so the hydro washer wouldn't sink for the first test. And for the second test, we took off the tanks, and it was not watertight. The same amount of water exiting was entering into the hydro washer, but since the tanks were not there the tanks weren't there, it sunk and it successfully rose. So room for improvements would be to completely water seal the hydro washer so that the weight of the water that's entering through the hole pockets and everything won't affect it. Move around parts to fit that bulge pump on the left, and lower the placement of the tanks with better balance. And here's Wayne to conclude our presentation.
Hello, my name is Wei Xiang. So for conclusion, we designed a hydro washer for pool cleaning. It can be used for pool, or it can be used for some low water level fountains. Our products consist of 5 main systems, which are power system, navigation system, buoyancy system, control system, and cleaning system. So the advantages of our hydro washer are inexpensive, long-lasting, safe, high effectiveness, and easy control. The total cost of our products is less than $400, which is cheaper than the other similar product. Also, the product is self-charging, so people don't need to worry about the batteries. The effect of cleaning is very good, so just turn on our product. It can make your pool become very clean after a few minutes. In our in our old plan, we are using a very big shell. After some tests, we found that our buoyancy system cannot support that big volume. So we changed the big box into a smaller one. By doing that, we need to redesign some of our systems in order to make it fit in the new box. We did individual tests for buoyancy, cleaning, and control system. Because at the first time, when we put the whole box into the water, the battery died. Each system works pretty well individually, but when we put every system together, they don't work well. I think because after we change from a big box into a smaller one, we need to remanufacture most of parts. Although we are very confident about the concept, we are not very professional at manufacture. So some dimensions of our parts is not that precise. We cannot make the whole system as accurate as we thought. Also, the tools and the materials that we can use are very limited. So it is very difficult for us to perfectly waterproof the whole box. When the box comes into the shell, this water can influence the function of our whole product. I think if we become more professional about the manufacture, we can make a better product. Thank you.